Hello guys, this is Christine again, and today we're going to get some more help for organic chemistry. Today we talk about how to draw an enantiomer and diastereomers. These are a little bit confusing concept in organic chemistry, so I do want to go through it again and help you guys to understand it better. So for enantiomers is superimposable image. They are different from each other. They are different from its mirror images. That's why we call it enantiomers. So when you draw enantiomers, you want to flip all of the R center to the S, to all the R configuration to the S configuration at all chiral center. So we want to notice is we flip all of them. It means that we flip all the dash to all the wedge, all of them. However, when we draw for diastereomers are totally different compound. So that's why they have really different physical properties. So for diastereomers, when you draw them, usually a compound will have diastereomers if they has more than 2 chiral centers. If they have more than 2 chiral centers, we'll consider if it has diastereomers or no. And also I have a formula that some possible enantiomers, and diastereomers. The formula is 2 to the n. N is the number of chiral center. So for example, if I have 2 chiral center, then I have 2 square, which is equal 4, that possible enantiomer and diastereomers. But if you have a meso compound, then this number may go less, like it may be less than 4. So let's go through some example, we understand it better. So for the diastereomer, when you draw them, you want to flip only one R configuration to S configuration. It means that you only flip dash to wedge at one chiral center or some chiral center, but you don't do for all of them. And then you keep the rest the same. So you only flip one. You only flip one, or you only flip some of them. You don't flip all of them. So again, diastereomers are different compounds, and they have different physical properties. So let's go through some examples so we understand it better. So for this example, let's draw enantiomers and diastereomers of this. So enantiomer of this, when we draw this enantiomers, the same we keep their, this is an enantiomer. I put an E, stand for enantiomers. I'll keep the skeleton the same. So here I have the skeleton the same. I flip all their wedge to all the dash and all the dash to all the wedge. So here I have a wedge. Now I flip it as a dash. And a dash I flip to a wedge. And the same thing here. I flip all the dash to all the wedge, and all the wedge to all the dash. So here I have another enantiomers. And when you define is R and S configuration, you see that it flip. So in here, for example, if I do this, I have this is 1, this is 4. Here, here is carbon. So I have this is 2. And I have this is 3. So if I imagine myself standing on this, I will have 1, 2, 3, 1, 2, 3. It would go counterclockwise. This is an S configuration. So, and also I have this. If I put in here, I have this is 1, this is 4, this is 2, and this is 2, and this is 3. So if I see I have 1, 2, 3, 1, 2, 3, this is counterclockwise. So this is also an S configuration. So if we have this is S configuration and this is S configuration, this will flip to R configuration. And this is also R configuration. You can check it out and try it out to see if it's true, but this for sure will be R. So we can apply in here and see if that is true. So I have this is 1, this is 4, this is 2, and this is 3. So if I go if I look at this and imagine myself standing in here, I have 1, 2, 3, it going clockwise. So this is for sure an R configuration. So we see that all our S configuration flip to all of our R configuration. Remember that all of them, not only one of them or some of them. And all our wedge flip to dash and dash flip to wedge. That's how you draw enantiomers. For diastereomers, I will put it as a D to stand for diastereomers. You only flip one character standard, and keep one character standard. So for example, if I keep this one the same, I have C chloride on a wedge, and then an ethyl on a dash. I keep it the same. However, I flip this one. I have OH is now on a dash, and then I have H is now on a wedge. So this is the diastereomers of this. And I have this is S, still get the same, but this configuration, I already flip it. So now this is R, not S anymore. You guys can check it out to see, to confirm it's correct. But we have S the same, but this is S flipped to R. And also from here, we can go to enantiomers. An enantiomer of this will have, I will flip everything, right? So I flip everything of this. It will give me an enantiomer of this. So I flip everything. And also you guys also notice that this, what is the relationship between this and this, this and this, or this and this? What do you guys think? So the relationship between this is diastereomers. This and this and diastereomers. Because they keep one the same, but they flip the other one. So these are diastereomers. And also we have this and this also diastereomers. And also we have this and this diastereomers, because they keep one thing the same, but they flip the other one. So here, that's one example, and let's take a look at this quick example also. So when we do enantiomers, again, I will keep their skeleton the same. However, I flip dash to wedge and wedge to dash. Okay, and also let's define our configuration. This is 1, this is 2, this is 3, this is 4. So if I go, this will be clockwise. So if it's clockwise, this is an R configuration. And I have this is 1, this is 2, this is 3, and this is 4. So if I go this way counterclockwise. This is an S configuration. So if I flip to here, I have this is now an enantiomer of this. All the R flip to S, and all the S flip to R. These are enantiomers. And let's draw their diastereomers. I keep one thing the same, but then I flip the other one. So I flip this one, will go to dash on Cl, and then on a wedge on hydrogen. And then I draw an enantiomer of this. I will flip everything. This go to Cl. This go to an H. This go to wedge of a Cl. And then go to a dash of an H. So you can see that this, I flip all of them. So this is an enantiomer of this. And again, the same as above. These are diastereomers. These are diastereomers. And you notice one thing, we have, this is R. Now we keep it the same, it's still R. But now this is S, we flip it, so now this is another R. And we have this is S, this is S. But one thing you want to be careful, really be careful, is that this is really tricky, because these two compounds are actually the same. So now, even though we have 2 chiral standard, it's supposed to be, we have 2 to the 2 squared equal 4. That's supposed that we have 4 enantiomer or diastereomers. But in this case, because we have these are meso compound, so they are actually impossible mirror image. They are the same. So we only count them as 1. So now we actually only have 3. We don't have 4. We only have 3. So why do I know these are meso compound? I already made a video that you guys can check it out. But in here, we really know that we have this compound has a symmetry. It has symmetry right here. And also we have an S and an R configuration, both of them in the same compound. So this is a meso compound. So if this is a meso compound, this and this are not enantiomers, they are the same. Meso compound does not have enantiomers, so they are the same. So we only count this at one compound only. So actually in here we only have 1, 2, and 3. So these are enantiomers, they are diastereomers. We only have 3 compounds. And this does not have an enantiomer because this is a meso compound. Alright guys, so that's it for today, and I hope that you guys found this video helpful. Thank you for watching, and good luck with your organic chemistry.